everyone. Today we're going to talk about parabolas. You're probably wondering, why are we talking about parabolas? We've talked about these before, but that's because we're going to add in just a little bit more. All of this first box here, our equation of our parabola, should be familiar. This we've done before. This whole box here was from section 7.5 and 7.6. So we know parabolas pretty well. We know our vertex form of them. That tells us the vertex. Inside with the x is the x value of our vertex. Outside is our y value of our vertex. We did also see this sometimes rewritten, where we put that k over with the y. Just remember, if you have it over with the y, our kind of quote-unquote inside with the y, then it's the opposite sign. We know our a value tells us if it opens up or down. It also tells us that vertical stretch or shrink. If we have it all multiplied out, we know how to find our vertex. We're going to take all of that and we're going to take it and just adapt it for this second part today. We are now going to have parabolas that are also going sideways. Our formula is very, very similar here for a sideways parabola, except our x and y are switched around. Our x is the term that's alone, in other words, the one that's not squared. Our y in here is that term that's getting squared. And then everything else, if you kind of think about the wording the right way, is very similar. Inside with the y is the y value of the vertex. So be careful of that because it does kind of flip-flop. Outside here, or again, we could rewrite it so that it was over with the x, is the x value of the vertex. Our a value tells us how it opens. This time it just opens right or opens left. It also still tells us that stretch, but instead of being a vertical stretch, now it's going to be a horizontal stretch. But really, I'm just going to turn my paper on its side. If it's all multiplied out, well, the same formula that we used before for our vertex is the same. It's just, again, flip-flopped. So let's see some problems here. As I'm looking at these, the first thing I'm paying attention to is that only one of my variables is being squared. That is what is going to tell me if it's a parabola versus one of our other conic sections. The second thing I'm going to do when I'm looking at these is decide, is it an up or down parabola or is it a side-to-side parabola? Number one here is y equals, so that means it's up and down. Our -2 means that this parabola is opening down. I know everything about this parabola. My vertex is at -3, -4. I'm going to go over to -3, -4. I'm going to draw my vertex. And then we also know our stretch. This is that one, because it's opening down, I'm probably going to turn my paper over. I can't do that for you, but this is what I would do. And then I'm thinking about my parent function and how that moves. I used to go over 1, up 1, but I'm stretching that by 2, so now I'm going to go up 2. I have symmetry. Well, I can't fit any more points on, and so that's good enough for this one. There we go. There's our parabola. All right, let's switch over to number 2. Number 2 here. Only one of my variables is being squared. That means I know it's a parabola. But what's being squared? My y is being squared. So I know this is going to be a sideways parabola. The -2 means that this parabola is going to open to the left. Now let's figure out everything else we know about it. I do know my vertex. Inside with the y, it says +3, so my y value is -3. Outside, I have a -4. That's my x value. My vertex is at -4, -3, so I'll draw that. And then I'm going to turn my paper so that the left-hand side is facing up. When I turn it so the left-hand side is facing up, now I'm just thinking about my original parent function and how it stretches. I used to go over 1 and up 1, but I'm going to stretch up and I'm going to go up 2. And then I have symmetry. So almost the same shape, except opening to the side. Now, of course, you could plug in values. If you were going to plug in values to find your points for this graph, you still want to have your vertex, -4, -3, but this time you want to pick y values. So if I were picking some y values, I would pick -2 to plug in, and I would pick -4 to plug in. I might pick -1. We know that's off the graph, but you could figure it out. If I plugged in -2 for y, I would get -2 for x, and that was this point here. So you can absolutely still go back and use your XY chart. All right, now like with our circles, we are going to have some here where I need to complete the square to figure it all out. Even without completing the square, though, I still know a little bit about number 3. I still know that number 3 is going to be up or down. I don't know which yet, but because my x is being squared, I know that this is an up and down parabola. So I'm going to kind of group my stuff together. I'm going to keep my x squared and my 4x. I'm going to move my y over to the other side. You can move your 1 if you want. You don't have to. But we're going to have to kind of, I don't know, keep it organized at some point. So I'll go ahead and move it this time. I'm going to add my y over to the other side. I'll also add my 1 over to the other side. And now I'm going to complete the square. 1/2 of 4 squared means that I'm going to add on 4 to both sides. When I now factor, this is going to be x plus 2 all squared. And over on the other side, I'm going to have y plus 5. I now could read everything off. This is our kind of alternate way to write this. My vertex, let's see, in with the x is a plus 2, so it's going to be at -2. Over with the y is a plus 5, so it's going to be a -5. My multiplier out in front here, well, there is no a value, so I could write it in. My a value here is 1, which means no stretch, right? I just have my normal old parabola, my parent function parabola once I move. It's going to open up. I'm going to go over to -2, -5. 1, 2, 3, 4, 5. Here we go. And I have my regular old parabola. So I'm going to go over 1, up 1. I'm going to go over 1, 2, up 1, 2, 3, 4. Maybe I could also fit in 3, but that's okay. This is enough. And there we go. Nice smooth U shape. Very similar thing happening on number 4. But number 4, when I start looking at number 4, I notice that my y is the thing being squared. So even though I don't know 100% yet what's happening, what I do know is that this is a sideways parabola. I don't know which one it is. I highlighted in the wrong color here. But I do know it's sideways. So I'm going to go ahead and rewrite. I'm going to keep my y's together on one side. I'm going to move my x's over to the other side. And I'll go ahead and move that plus 3 as well. I'm going to complete the square. So I'm going to add in 1 on both sides. And when I do that, I get y minus 1 all squared equals x plus 4. Again, I know my vertex now. Over with the x is a plus 4, so the x value is minus 4. Inside with the y is a minus 1, so it's plus 1. There is no stretch out in front. There's no negative out in front, so this is going to open to the right. -1, 2, 3, 4, up 1. And when I turn my paper so that the right-hand side is facing up, now I just have my normal old parent function graph. Over 1, up 1, over 1, 2, up 1, 2, 3, 4. My symmetry has the points on the other side, and I'm going to connect with a nice smooth U. Oh, pretend like that actually worked. All right, a couple more, and then you're going to have some of these that you need to practice. I want to do number 7. Number 7, you actually should know without any rewriting, because this was one of our parent functions way back at the beginning of the year. However, let's rewrite it like we did the other day. I'm going to square both sides. So I get y squared equals x. This has a vertex of 0, 0, and it is a sideways parabola opening to the right. So I'm going to go ahead and I'm going to draw that sideways parabola. Here is my vertex. I go over 1, up 1. I go over 2, up 1, 2, 3, 4. And likewise on the other side. But because I squared both sides, I need to consider what's happening in this picture. What I really need to consider is my domain and my range of my original function. My domain, what am I allowed to plug in on this square root graph? Well, I can take the square root of 0. I can take the square root of any positive number. I cannot take the square root of a negative number and get a real number that I know how to graph. We do know how to take the square root of negative numbers, but how the heck do I graph I? And so our domain here is going to be greater than or equal to 0. Our range, well, let's think about what's happening. If I plug in 0, I get 0. If I plug in positive numbers, I get positive numbers. Our range is also greater than or equal to 0. That means when I have my graph down here, I don't want this complete parabola. I want just the part that's in quadrant 1. So I'm going to ignore those points on the bottom. I'm not going to draw those, even though it's kind of part of what I was doing. Question number 8, same thing. Let's actually do domain and range first before we draw our graph. Our domain, I'm going to leave for a minute. I'm going to do the range first because this is a little bit backwards. Let's see, what am I allowed to plug in into this square root? Well, I could get 0, so I could plug in 3. I don't want any negatives, so I can plug in 4. I could plug in 5. My range is going to be everything greater than or equal to 3. Let's see what's happening with my domain now. If this whole square root was 0, that's kind of like my starting point, then I would start at 2 because I'm adding 2. If it was anything bigger, then I'm adding 2 to some positive number. So my x values are going to be greater than or equal to 0. So now that I have that, now I'm going to go and manipulate my equation so that it's a little easier to graph. All right, let's see. First thing I think I would do is minus 2 onto both sides. And now I'm going to square both sides. I get x minus 2 all squared is equal to y minus 3. Oh, hey, I can read off everything I need. This is an up and down parabola. And my vertex is at 2, 3. I don't have any sort of stretch. So let's go ahead and draw it. 2, 3 is my vertex. Over 1, up 1. Over 2, up 1, 2, 3, 4. And likewise on the other side. But wait, let's think about that domain. I want my graph to start at x is equal to 2. So this is kind of my starting line for my x's. I want my graph to start at y is greater than 3. So the only piece of my graph I actually want to draw is this little piece over here. All right, one last question, and this is from your homework because it comes out a little funny. I, again, already know that this is going to be an x squared graph because an up and down graph because my x is the thing that's being squared. So I'm going to go ahead, I'm going to move my y's over to the other side. I might move my number over to the other side. Actually, let's do this one where I don't. Let's do this one where I leave my 4, but I'm going to leave some space there. I'm going to go ahead and complete the square. Because I'm keeping everything over on the left-hand side, when I add in 4 to keep it balanced, I'm also going to subtract off 4. Now I have x plus 2 all squared. That came from this perfect square trinomial. And I have minus 8. Notice I didn't touch that minus 8y yet. Now I don't want my equation to be minus 8y equals. I want my equation to be y equals. So I'm going to go through and I'm going to multiply everything in this equation by negative 1/8. This is how I'm going to get my equation. -1/8 times x plus 2 all squared plus 1, oh, pretty nice, is equal to y. This is now a whole lot easier to read off your information. My vertex is -2, 1. My a value is -1/8. So that means it's going to open down and it's going to be a vertical shrink by a factor of 1/8. That's going to be tough to draw, but we hopefully kind of know what it looks like. All right. Of course, bring questions to class on any of this. Good luck on the homework. And I'll see you all soon. All right. Thanks, everyone.